All right. Let's see. Welcome back. So we are well into the 10th week. We're almost at the end. And this week we introduced the MongoDB, right, to be able to store data permanently for long term. And we introduced Mongoose as the Node.js library to interact with the database, right? That gives API to be able to insert, query, update, delete data from the database. And we went through an implementation of refactoring the code that we've been working for a couple weeks, where we used to store the data in local variables, right, in arrays, and instead of doing that, what we want to do is to store it permanently in the database. So we've been doing that refactoring. Last time we started that refactoring last time we met, and it's somewhat what is expected that you do in the new database assignment that went out this week, right? It's pretty much the same work. So hopefully, what we're doing here in class will show you what the pattern is, right, on how to do it, and then you would apply the same techniques that we're introducing here to your assignment, right? And then once you have a chance to play around with that on your own for the assignment, then you should be able to apply those techniques for your own project. Okay. So I'd like to go back to where we left off last time we met. Several of the commits that we're demonstrating the various refactoring efforts that we started. So let's go back to I believe where we left off. Let's see. Web dev older. Let's see where did we leave off? I believe we started. Declare Angular OMDB application. Where is the start? There was a particular. Get MDB from reference. Find movie by MDB. Push my all the copies. Start. I think this is where we started, right? This is where we started last time we met. And so I'd like to just review real quick what we did. Certainly we said that we were going to use the Mongoose library. So you'll need to npm install the Mongoose library. Don't forget to use the -- save option to make sure that it updates the package JSON file, right? So that when you push it to the server will open up the package JSON file and install the Mongoose library for you. So always make sure to use the -- save. And what we started doing on Tuesday, we showed that we loaded the Mongoose library. We created the connection string. I'm just reviewing, going over this real quick, just to make sure we're all on the same page. We created a connection string that is friendly to a local environment, right? When it runs locally in your local database, and it's also friendly to the remote environment, right? That depending on where it's running, it knows which database it's connecting to. We also passed along. We created a database connection using that connection string, and then that connection string we passed it along to the where is it? We passed along that database connection to our application, in server.js, right, where we were loading our application entry point that starts our server side implementation. We passed an instance, the instance of the database connection and the instance of the Mongoose library. The database we are passing along because we want to share that one single connection across the entire application. We don't want to have to open and close the database. Those are very, very expensive objects to just throw away. We also got started with implementing the schema for the various entities that we want to manipulate. We declared the user schema. We also implemented the movie schema, right? For the user schema, we're going to use it so that we're going to store user information such as first name, last name, username, password, and so on. For the later on, we're going to do the movie schema, right? I think, did we get to the movie schema? Did we? I don't remember. Maybe not. And for the movie schema, we're gonna use it so that we can store the cache information about movies that we've liked, right? To keep track of these movies. So we're gonna use the user schema for being able to log in and register and keep track of personal information. We could add here phone numbers, addresses, things that are related to the user. Up to this point, we just have roles, username, passwords. We also notice that we're overriding the default name for the collection that is going to be used to store the data. Right. Here, I am specifically saying that the collection that I want to use in the database is user, right, as opposed to using the default name. I don't like the default name. It uses a pluralization algorithm to choose the name of the collection. I don't like that, so you can override it here. Once you declare the schema, we declare it in a separate file. We load it from the model. We load that schema, and so that we can use that schema in the model. Now, notice that we seem to be the term model seems to be overloaded here, right? We already had a user model, right? And now we have this again, another user model. And the model here that we're going to be declaring here in our where is it? This user model that is being declared inside of the user model, right? It's a little misnomer, I guess. The user model, this file, the user model.server, its job, right? Its reason of being is provide a high-level API to the rest of the application, right? It provides all the CRUD methods and to the rest of the application, right? So the internal implementation of those CRUD functions is up to us. Whatever we want to do, right? I mean, we could have decided to store the data in a CSV file or an XML file, right? Just lately we decided to store it in local variables, right? And now we're going to be changing that implementation to use a database. But you'll notice that the CRUD API stays the same, right? So the rest of the application is shielded, right, from low-level implementation details that can change over time. See that? And that's the beauty of interfaces, right? As long as you maintain the interface, right, and you provide the same functionality, you're free to change the implementation underneath, right? That's the beauty of abstractions in general. Right, we humans are abstraction animals, right? We love to, put things in black boxes, right? And give as long as you give a consistent interface to the outside world, we don't really care what's inside, right? And we see this every day with the way we interface with computers, screens and user interfaces and keyboards, or when you drive a car, right? As long as they give me steering wheel, a shift, and maybe a couple paddles, I can drive a car, right? Regardless of whatever the implementation is. So same thing here, right? So interfaces allow us to do that. So internally, the implementation of this model, it's going to use this low-level model, right? This is Mongoose model, yes? This is Mongoose implementation of the model which uses a low-level API to actually talk to the database. Now, this will provide us with functions such as find, create, save, delete, remove, update. Yes, it provides us with low-level functions, an API that allows us to communicate with MongoDB. So this user model.server, right? This file serves as the interface between these two worlds, right? Between the object world, right, and whatever physical scheme, whatever physical storage we choose to implement. Make sense? Right. And yeah, I mean, again, we humans love to create these abstractions and abstractions and abstractions, right? MongoDB, again, it's another abstraction, right? We have this notion of JSON representation, right? And objects and arrays, and that's a high-level abstraction layer. Underneath, it's just going to be stored in zeros and ones, right? But MongoDB provides this layer of abstraction and let us think about it in a higher level, right? Yeah, abstractions within abstractions. Oh, yeah, so this object here is going to provide the API to talk to the low-level database. I renamed in the schema, right? In the schema, I renamed the collection to be project OMDB user instead of just plain old user. All right, so to insert the user in our model, right, in the CRUD implementation in create user, we are refactoring. We says we no longer want to store it in a local array. Instead, we are going to do an insert in the database, right? And to do that, we use the create function of the model. We take the user instance. This user instance that is coming, it's coming from where? From the Angular client, right? The Angular client provides when you are creating a user, I believe it creates it provides a username, password, maybe an email. I don't remember, but it's in the registration page, right? So when you register, it provides that object comes here. This object. Notice that it's we're going to use the create method of the user model. The user model had been created from where? From the schema, no? Where is it? Yeah, the user model was created from the schema, right? So when it takes this object to insert it, when it takes the object, it's going to validate that object that's coming in. It's going to validate it against the schema that it was instantiated from, right? They're going to check to see that the fields the properties are correct, the data types are correct, right? If it's valid, then it will do an insert, right? It will insert the document into a database. Any fields that don't match, right, will be ignored. Okay, and once that happens, the document comes back. This document is the instance that would actually made it into a database, right? It will come back with an additional field, the _ID field, right? That uniquely identifies this record. Now, we've noticed that we've changed the implementation here from that used to be synchronous, right? We've changed it with one that's asynchronous. Right, this function call used to be a synchronous call, right? And so the thread, right, the single thread Node.js came in here, right? It's executing from top to bottom, from left to right, right? The single thread, and it was executing these 3 lines of code, and when it got to the return, it just came back, right? So that means whoever called this, right? Who called this? The service, right? The web service called this, right? That's trying to receive an HTTP request and an HTTP post, I believe, right? And it's that request is live, right? It hasn't been responded, hasn't been, the client, the Angular client, is still waiting for it, right? It sent this request and is patiently waiting for the response. An AJAX call came in, right? To resolve that we haven't generated a response back, but here we're changing the implementation to be an asynchronous implementation, right? This function call right, is not going to be a synchronous call, right? The thread that comes in here is usually when a thread comes in and makes a function call, right? It waits for the function call to come back before it continues, right? But in this case, this is not going to be a synchronous call. It's going to be an asynchronous call. The thread is not going to wait for this function to come back, right? Because this function could take a couple milliseconds, a second, right? It could take a while, right? It's a network connection to the database. So instead, the thread makes this. A new thread will spawn and deal with this request, right? The main thread is not going to wait. It's just going to go back, right? It's going to come back from this function right away, right? Having made that request. Meanwhile, that request is still going. The main thread went back to listening for other incoming requests, right? It has other 100 users that are sending requests, right? So the logic that we used to have, that used to be asynchronous logic, we need to change that, right? Because whoever called this, right, it's expecting the function to come back with a user, right? But this came back and didn't even return anything, right? So we need to go change that too, right? We need to change this from a logic of a synchronous logic, which is the most common that we use in everyday programming, right? We need to change it to an event-driven programming, right? This is a complete different style, right? It's a style that works around notifications, right? You send an event and you forget about it, right? You keep doing your thing, and at some point somebody's going to interrupt you and says, "Hey, I'm done." I says, "Oh, wait a minute. Okay, now I'll go back and listen to what you were saying." Right? It's a completely different style of programming. And sometimes it's a somewhat alien to the way we think, right? We tend to think sequentially. Even though our brains are doing lots and lots of things, our consciousness focuses us in a sequential stream of events, right? Even though our brains are all very, very parallel, it focuses us just moving forward in time, right? So we have to change this, the implementation of this, right? So let's see how we implement it. What do we need to do? So in that style of programming, we need to be able to declare notifications. We need to declare the capability of being interrupted at some point with a callback. It says, "Hey, here's what you asked me for a while back," right? So to do that, you're going to use the Q library, the Q promise library. And you'll need to install this, right? The Q library is not available by default, so you'll need to do an npm install Q -- save, right? Make sure that you do the dash so it updates the package JSON. And what we're going to do is we're going to use the Q library that we load, right, to return something, because we need to return something. Whoever was calling this was expecting something. It was expecting a user, right, from a synchronous call. Instead, we're not going to return the user because we don't have it yet. We don't have the user yet, right? There's a thread waiting for it at some point. Yes. Instead, we're going to return a promise. We're going to return a promise to whoever was waiting, expected a user, and the service, the web service, disappointed that it's not getting a user. That instead it's getting a promise. It says, "Oh, okay, at some point you promised to give me this, right? Okay, fine. I'll give you a function, right, for you to notify me when the promise is fulfilled." Okay. Again, it's a different style of programming. It says I don't have the user for you yet, right? And I don't want to wait for it, so instead I'll give you a promise that at some point in the future I will have the data for you. Okay, so that style works as follows, right? You instantiate a deferred object from the Q library. You make the asynchronous call, which we're not going to wait for. We're not going to wait for this. We're going to assign a new thread to deal with this asynchronous call, right? Instead, we just We make this and we just pass by. We don't wait for this function to come back, right? So we fall into this return, right? It says we don't have a user, right? So instead, I'll give you the next best thing. I'll give you a promise that at some point in the future I'll have this user for you. So the web service, disappointed that is not getting a user, that instead, so this was the original function call, right? This was the original function call, and I'm expecting a user. It was expecting that the function, right? This function is a synchronous call, right? Meaning I call the function and the function is going to come back at some point. So I'm waiting for this function. I'm going to wait for this function. The normal thread execution is that the thread blocks, waiting for this function to come back, right? And then it was hoping to get a user and to log in that user, make sure that user was a currently logged in user, and then respond to the client that is patiently waiting for this user, right? No more, right? Instead, this function call is not going to receive a user. Instead, it's going to receive a promise for a user, right? So actually, this left-hand side is actually not needed anymore because we're not getting a user. What we're getting is a promise. So this function, right, comes back with a object, right? It comes back with a promise object, right? Instead, and that promise object has a then function. That then function allows us to says, oh, I'm not getting a user. I'm getting a promise. So it allows me to tag along, to register a function, right? That says, well, fine. At some point, you call these functions with the data that I was expecting at some point, right? So it allows me to provide two functions. One of them, it will be invoked when eventually the data comes back, and the other one if something wrong happens, right? So let's open these up together. Let me open this in a different tab. And this is the use the queue promise. So the way this works is that and we come back with a promise. Internally, the create method, right? It's asynchronous. It's ongoing. It takes a couple of seconds. When it comes back, the create method invokes this function. Says, "Oh, I'm done. Right? I got the object. I got the user I just created, and here it is. I give it to you." Or if there's an error, I'll give you an error object. And what this does, if it's an error, what's going to do, it's going to defer, or it's going to reject the promise, meaning, I'm sorry, I know I promised you a user, instead I got an error, okay? Or if there is no error, then we can fulfill the promise, right? I think a better name for this function will be fulfill. Fulfill, I'm fulfilling the promise, I'm resolving the promise, right? And I'm passing the data. So the way this works is that this reject, here the model, right, that was expecting a user instead is getting a promise, right? It registers two functions. So one of these two functions is going to be invoked, one of them, right? This function, the error function, will be invoked if we reject the promise. You see that? Yes.
I have a question. So the user model dot create itself is asynchronous call.
Yes.
And it also return another promise to its caller.
No. So the user model, unfortunately, the implementation MongoDB do not support promises. Instead, they support callbacks.
But will return a deferred.
This is a callback.
Oh, that's okay.
Yeah.
So it's not an asynchronous call.
It's asynchronous, but it does not use the promise API.
Oh, okay.
Okay.
Yeah.
If we didn't have if we didn't use the queue promise API, instead we could do the same thing. We could put here a comma callback, right? Which we did that a while back, right? We were passing these callbacks, right? And then when we receive the data, right, we would just call, right? And that's fine. That's how we used to do it before we had promises, right? And what you would end up with is lots and lots of callbacks everywhere, callbacks everywhere, right? And if it's a single asynchronous call, callbacks are fine, right? The problem starts when these network connections are many network connections, many asynchronous calls, right? And then you need to synchronize them somehow, right? That I send this asynchronous call, I send another asynchronous call. There's no guarantee on who's going to come back first, right? But if I need to synchronize them, I need to say, well, they have to happen in a particular order, right? Or I can't continue until they're all done, right? I need to wait for them, right? Then what you end up with these nested callbacks nested, right? A callback, sending, waiting for another callback, waiting for another callback. So you end up with these very nested callbacks, right? That it's very hard to follow, right? So to make it a little more manageable, they came up with this solution, the promise interface. So instead of passing callbacks, what I'll do is I'll give you an object that allows you to register a callback, right? So don't pass me the callback. Instead, I'll give you an object for you to register your callbacks, right? And what this allows us to do is write these nested registrations in a sequence. They look as if they were sequential, as opposed to nested. We'll use one of these in a minute, right? For instance, we need to do a couple things, right? For instance, we need to tell the user that it likes movies, and we need to tell the movies that it likes users, right? There's a many-to-many, and we want these to happen both, right? It makes no sense to tell a user that likes a movie, but then the movie doesn't know about the user, right? They both have to happen, right? To maintain consistency, right? We don't want to happen that yes, we added the movie to the user, and the user interface shows that this user likes this movie, but when we navigate to the movie doesn't know about the user, right? It would be an inconsistency, right, of the application. Same thing for if you have ATMs, right, and somebody's depositing, the other one is withdrawing, and we want to make sure that at all times the account is at a consistent state, right? That if I access it one way, it says that I have $100. The other one, if I access it in some other way, it says that I have $50. It would be inconsistent, right? We have to make sure that if we're making a lot of operations with many asynchronous calls, that they come back to a consistent state. Make sense? So if for instance, typically the classical example is that you're transferring money, right? Or usually it means that when you transfer money, it means that you need to update two accounts at the same time, right? One of them you need to withdraw from one of them, and the other one you need to deposit, right? And so you wouldn't want to happen that you have an inconsistent state where all of a sudden you withdraw from one, right? And you see that there's no money in this account, and then but you don't see the money in the other account at some point, right? It says, wait a minute, where did the $100 go, right? You want to make sure that you're withdrawing from one and you're depositing in the other one, and at no time do you want to give the impression to the user that wait a minute, I transferred, I see that this went down, but I didn't see this one go up, right? Although Bank of America does this sometimes. When I pay my credit cards, it says, okay, I see that it went out, but I don't see it go in, right? And then a couple of days later, I see that it goes up, right? That inconsistent state, right, is unacceptable, right? It makes people, what happened here, right? So anyway, so to deal with this, yes?
So the user model dot create is like a mongoose in.
Yeah, it's a mongoose.
Insert operator.
It's an insert, yes.
And it got also got user model dot read and user model dot.
So there's a couple, right? There's a couple finder methods, right? There's a find method that allows you to retrieve things by giving a predicate. There's a find one. There's a find by ID. There's a create, update, and remove, and save.
Lots of user model here. I got a little confused about the naming.
Yeah. So user model is the user model is Mongoose's object that we instantiated earlier. We instantiated earlier here, right? From Mongoose. It says, Mongoose, create me a model for this schema. Okay, I'm going to give you the schema, meaning all objects that I'm going to put in the database, or I'm going to update, or I'm going to find, they have to adhere to this schema, right? All objects look like this, and we give it the schema, right? And the operations are all the CRUD operations, right? We are providing a CRUD API to the upstream to the rest of the application, but it has its own CRUD operations to talk to natively to the database. Okay. Yes.
So, so if there is no connection name user present in our database, it would create.
It creates it. Yes.
Suppose it is already present, then it would directly connect it.
It would just connect to it. Yes.
And suppose the type you have mentioned in user schema doesn't follow the contract, then what will happen in find method?
It would only retrieve the ones that match, right? It might. I mean, it could find like for instance, as we said earlier, right? The MongoDB doesn't enforce the schema, right? So you could have documents that have different names, right, and different data types, right? And so, for instance, say you had already inserted all sorts of objects that don't match the schema that you're now declaring here, right? Somebody went in and used Mongo client, right, and mocked around and inserted documents that don't match the schema. That's fine, right? Mongoose doesn't know about it, right? So if you search for if you do a find by ID and you provide an ID of an object that does not match the schema, right? It will retrieve the object and it'll validate it against the schema. So the fields that don't match, right, will not make it into the object that you get back, right? So if you're expecting username, first name, last name, and instead you had something, the fields are called first and last instead of first name and last name, those fields would not make it into the object that you get back, right? Because those are not, right? Even though that data is still in the database, it just doesn't match the schema. Okay, same thing if you try to insert, right, and use properties that don't match the schema, right? So you call the first name, you use just F and L or something, right? Those would be ignored.
Isn't that a bad thing? Because like you work on a project, like after 6 months, you have one more new column in your collection.
Yes, you have to update your user schema.
So if I update my user schema, then
they would see it.
Then my old documents won't get validated, right? Because old documents won't have that column.
Yes.
And the new documents only get validated. So it won't be like in either way. You at a point you will only follow only one type of scheme.
That is the point, right? The point of using users of Mongoose schemas is to do some validation, right? Is to force validation. Is to have a programmatic assistance, right? To do validation for you, right? If you don't want any validation, that's okay. You can do that too. There's plenty of other libraries that have no validation. There's MongoJS.
So is there anything in Mongoose where you can provide this relaxation that you don't do validation, just you don't do any validation, just give me whatever there is in my
raw
data.
The raw data? No, Mongoose would not be the solution. Using native, so MongoDB provides a native API to talk to the MongoDBs, and that doesn't do any. You can do raw schema manipulation. Yeah. And that one's it's so powerful. It's really cool. For instance, you can if there's no collection in there, you can use dynamic collections. You can just add the name of the collection on the fly, so that people could just be storing with collections that don't exist yet, right? And the objects that come in are stored verbatim into those collections. Very powerful. But again, for those of us that that are using that are accustomed to strong typing, strong data typing, would come from a SQL point of view, where we are used to schemas. I know that you're using you're running a product or a project that doesn't want schemas because you're trying to connect to any database, right? And yes, you need something that is more meta.
Yeah.
It's something that's more generic, right? So yeah, for that there's other libraries. MongoJS is one of them. MongoJS is it's more of a low level library that allows you to work with native collections and native. You could do that. You could use that. Another thing that you could do is that notice that when you're creating the schema, the schema themselves implement the schema. Notice that the schema itself is an object. See that? That object is a JSON object. That JSON object could be changed. Right? I could programmatically say that the schema is this object, and at some point, as the program is running, right, I could have this be part of an object, right? That I can a raw JSON object that allows me to just declare, add, or remove fields, right? That I can then programmatically, dynamically use it to instantiate my schemas, right, and instantiate my models against that schema. Okay. Implement. Okay, so yeah. Right. So the point I was trying to make here is that when you call the reject, it calls this function in the then. So this allows you to configure the two functions to be called whenever the callback comes back, and you are either going to call this one, or you're going to call that one. Right? So if it resolves, it calls this one. If it rejects, it calls the other one. Make sense? All right. Handle. Okay. Right. So we're just going to go one by one implementing these. Right. One by one, refactoring all the functions. So the find user by ID. Right, accepted a user ID, and it used to be implemented synchronously by iterating over the array, looking for those users that match the ID. And if it found it, it would just return that one user, right? So we're gonna refactor it so that it creates a deferred object. It makes an asynchronous call, and then it returns a promise immediately. All right. Hopefully you're seeing that pattern here, right? You instantiate the deferred object, you make the asynchronous call, whatever it is, and then you return the promise, right? The asynchronous call here, we're using one of many finder methods that are provided by the Mongoose model. This is the Mongoose model we instantiated earlier. It's the same model. Before we use a create to do an insert, right? Here's another one, find by ID. And you can guess what it does, right? It looks in the collection for documents whose _ID property is equal to whatever you pass as an argument here. Okay, if it matches, it comes back and it retrieves either an error if it failed or a document. Okay, and we're going to do the same thing, right? If it's an error, we're going to reject, and if it's not an error, we're going to resolve. The web service that used to call find user by ID used to be a synchronous call, right? It expected the user. Instead, what it's getting back is what? A promise. A promise that at some point in the future, I will give it to you. So the promise has a then function that allows us to register two functions that will be invoked, one or the other, right? If it's rejected, right? If it comes back because an error or something, right? When the server comes back, if it's rejected, it will if it succeeds, right, it resolves. There's no error. It resolves and it calls the other one, right here, this one. Okay, I did start the broadcast, right? Yeah. Okay. All right. Now the implementation that we had earlier was synchronous, right? Was synchronous, and notice that we need to do two things here, right? One, fetch the user, and then go that this user likes. See that, right? And populate the movies in the user movies. You see that movie user.likes movies. This was because when we went to the profile and we retrieved the user, the profile wanted to display not only the user information, first name, last name, and whatever, right? But we also wanted to display the movies that this user liked, right? So this used to be synchronous and another synchronous call. And our expectation is that these things happen in that order. We first need the user. Once we have the user, we use the user likes to fetch the movie objects for those likes, right? Has to happen in that order. But now these things are asynchronous, right? This is going to be asynchronous, and that's going to be asynchronous. But we need it to happen in that order. How do we do that? That's a problem, right? Because if they're both asynchronous, right, I can't guarantee that one is going to happen in a particular order, right? So the promise is going to allow us to do that, right? Typically, if we don't use promises, we would have to use callbacks, right? We would the callback for this would have to be fed into the callback for this one, right? And each one, so these would be nested calls, right? And you would get code that is very, very embedded and nested and nested and nested, right? It makes it hard to read. So instead, we're going to use promises. So first, we're going to focus on this one over here. This how to deal with that asynchronous call. We'll then later deal with this one, okay, a little later. So this one, find user returns the promise. We get the document back. Presumably, it's that user. And we're going to do the find movies a little later. Okay, we'll do that a little later. So right now, it's just returning the user object, which has the personal information. It doesn't have movie information, not yet. Okay, we'll come back to it a little later. Another thing that I wanted to point out is notice the error. See the error? If there's an error, I'm going to send the status of this HTTP request response. I'm going to send it as a 400. There was an error. Okay, so that when the AJAX call comes back to the client, to the Angular client, if you remember, the Angular client will also use promises, right? Also uses promises, and also has two functions. One of them, if successful, if you get a 200 or 203 or whatever, right? Or if you get an error, 100, it'll call the error function, right? And so you could deal with those errors on the client as well. So this will force the client to handle that error, right? And I'm sending the error object. Any messages in there, any status information will be part of that error object. Okay. All right. Okay, so we did that. So find user by credential. This one is used by the login, right? In the login, we passed in an object with credentials, username, and password. Again, it used to be a sequential, asynchronous call. We came back with either a user object or null. Instead, we need to convert it into an asynchronous call. Again, the same thing. We do a defer. We make the asynchronous call, and then we return the promise. Okay, hopefully you're seeing that there's a pattern here, right? It's always the same three things. And in the asynchronous call, we're going to use yet another finder method, right? Before we used find by ID, right? In the previous example, we used find by ID. Here we're looking at another finder method, right? It's called find one. Find one. In the next slide, I believe we're going to use another one called just find. So we're going to look at those three: find one, and find by ID. Okay, and really, as we'll see in a minute, the only one that you really need is just the find. Okay, that one is used. You can be used for everything you need, right? The only caveat we use using that find method is that it always returns an array. an array of objects, of documents that match a criteria, right? That array could be an empty array if no objects match. It could be an array of one if only one matches, right? It could be an array of many documents that match a criteria, a predicate, yes? And oftentimes when we use that find method and we're looking for things that we know there's only one, okay, maybe we're finding in our predicate is find, we want to retrieve by its primary key. We know there's only one, all right? Or like this one, we're going to want to find it by username, and presumably usernames are also unique, right? And it's going to return an array of one. It's often the case that we forget that it's an array. We were expecting just one thing, but we're getting an array of one, and we forget that we should just retrieve the first one in the array. Okay, that's a very common error. So to deal with that common error, they created these other finder methods. Right? These are convenience finder methods, right? That make the interaction with the database, that much more expressive, that much more easier. It says, oh, I just want to find one, or find by ID. I know there's only one, or find one. So find by ID is a syntactic sugar for finding where the predicate is _ID is equal to the ID that you give it, right? That's a syntactic sugar for that. This one is syntactic sugar for, give me a predicate, presumably it's for a unique instance, right? It's only going to match one, presumably. And I'll return to you just the one instance that presumably matches. Maybe the predicate doesn't really match just one. It might match several. But if it matches several, it'll return the first document that matches. Okay, but it's always going to be one, right? Because that's the name of the function, find one. Okay, so you can be guaranteed that this is a single instance. When we'll use the find method, we'll see that it's always an array, right? And we'll see that in a minute. Anyway, so here's find one. Here's a predicate, right? It's going to match the username and the password. So it's like an and, right? That the username matches and the password also matches, and returns that one instance. And we're going to reject or resolve, right? As always. And on the client side, on the service side, the web service, the one that made the call, it used to be a synchronous call, right? I make the synchronous call. You iterate over all the users, right? And you return to me the user that matches. Instead of this call returning a user, now instead it's returning a promise, right? And we need to deal with that. The promise again allows us to register the two functions, right? And one of them will be called if it's resolved, or the other one will be called if it's rejected. Okay, you see a pattern? Yes, hopefully you'll be bored with this pattern, and it'll be second nature to you, and you can use it in your assignment and in your project. Yes?
So those are two arguments, right? Those are functions.
Yeah, there are two arguments, exactly.
Is there any other
No, I believe there's just those two. We'll see another one because it's a promise, and there's another one that we'll see when you have many, right? In this case, we're doing one at a time, right? If you have several of them, right? Like you want to make 10 invocations, right? 10 asynchronous invocations, and you just need to wait for all of them to complete, right? And you're not guaranteed any, and you don't care the order. Here, we're gonna care about the order, right? Because we need to fetch the user first, and then the movies, right? But when you don't care about the order, right? We don't use the .then. We don't use the. There's another one. Is called q.all, right? And what it allows you to do is wait for an array of promises, right? So you make many invocations, and each invocation is part of an array, right? That they all return promises, right? And what the q.all allows you to do is provide this array of promises, right? And it'll just sit there waiting for all of them to come back, right? In no particular order, right? Once they all come back, right? You can then it provides a then method, right? It says .all, right? And then a .then when they all come back, and then you can continue after all these asynchronous calls are invoked. Come back and they're all they all come back with a resolve, right? If any one of them in the array returns with a reject, right, then you get this one is invoked. Okay, why did you have in mind?
Just asking, like, one of them is like a subset and
Yeah, no, those are the only two possibilities. Yeah. Okay. All right, so I think we're far along with the user. We need to now focus on the schema for the movie because we want to fetch movies too, right? And we want to fetch movies, populate the user with the movies, right? But we don't have a schema for the movies yet. So to do that, there is we implement a simple schema for the movie. Right now, we're just going to capture these three: IMDb ID, title, and poster. Right? Again, the reason we're capturing this is so that we're going to cache this data in the database. If somebody likes a movie, or somebody reviews a movie, right, or somebody comments on a movie, right, or rates it, the only place we can store information about that movie is in our own database, right? We can't go back to IMDb and say, please store it for me. We need to store it ourselves. If nobody ever likes a movie, nobody ever comments on the movie will not live in the database. Right? We will have no knowledge of this movie. Okay? Only if we need to remember anything about the movie. Right? And we are providing a default name for the movie. From our model, from our movie model, we are going to load the schema and create a model for it. So here we're loading the schema. We implement the movie model from that schema. So again, this is going to be Mongoose's model that will provide the API for us to interact with the database, right? We're going to use that movie model to refactor the create movie function. Okay. Again, the movie function used to be a synchronous call, right? Created a movie instance, right? And then to the local array, right? And then it just returned the movie. Well, no more. Instead, we're going to refactor that so as to insert into a database, right? So the way we're going to do this is that we're going to use the movie model we just created, the Mongoose movie model, and we're going to create an instance. There it is. We're going to create an instance. We're going to create an instance that is going to take as argument a JSON object with the attributes that have to match the schema that we just created, right? These are all lowercase. We're copying over the attributes from the argument that is coming through our method, right? And if you remember, this movie is coming from where? It's coming from somebody having clicked on the like button, right? Right, clicking on the like button, and the movie was rendered from the API, right? From the third-party API, right? We display the plot, we display actors, right? We display the director, the title, the poster, right? And that object, if you remember, all the attributes were capitalized, right? Capital poster, capital title, capital actors, capital director, right? They're all capitalized. But our schema, it's all lowercase, right? So what we're doing is that we're copying over all the attributes from the raw JSON that came from the third-party API. We're copying it over into our own object, right? In our own object, and we're using it to instantiate a movie model that we create here. So movie has a constructor, right? It has a constructor that allows us to create new instances, right? And we can pass it an object, right, to copy from, right? But it has to have the right schema. It has to have the right schema, right? Now, why didn't we do this in the previous one? Like with users, we didn't do this, right? With the users, what do? We have the user object. and we used it to immediately do a dot create, didn't we? Isn't that what we did? Well, in that case, the user object we generated from our Angular client. We generated the object, right? In this case, the object, we didn't generate the object. It came from a third-party API, right? It had its own schema, yes? So we need to do a conversion here, right? We need to clean it up, right? We need to convert it into our own schema, as opposed to the schema, the object is coming from Angular. We implemented the Angular client. We can decide what the schema that the Angular client is. It just happens to be the same schema that we're using on the server side, yes? So we didn't need to do any conversion, right? That's one thing. The other thing is that, notice here that we're using a dot save. Before we used a dot create, didn't we? We said user model dot create, and then we pass the object in there. Well, save is a function. This is a typo. It's supposed to be lowercase movie. It's this movie. It's this movie. Okay? It's this movie object. That movie object has a save method that allows it to, once it has an instance, right, all the values that it needs, it can be now inserted or updated into the database, right? So dot save is I think a better name would be upsert. Upsert is meaning if the instance is not already in the database, do an insert, right? If it's not already there. If instead this is an object that was retrieved from the database, meaning it already exists in the database, and I have it, and I do a dot save, we do an update, right? So this is a very smart method, right? If I have an instance of the object right here, it's not yet in the database, and I do a dot save on it, it doesn't insert. It's as if I would do a create, right? It doesn't insert, right? But instead, if this is an object that I retrieved from the database using a find or something like that, find one or find by ID, right? And I retrieve the object and I have it now, and I do a dot save, it would do an update. Make sense? So dot save is a function. It can behave as a create, or it can behave also as an update. Okay? And we'll come back to this. We'll have plenty of examples of using dot save. Right? We'll see a couple more examples on how to use it. But I just wanted to point out that this is an alternative way. What we could have done is we could have created this object, this little object here, right? Do the conversion, without using the new. We just do the conversion, and then using that little that new object and do a movie dot create and pass the object in there. That would be an alternative. But I wanted to point out that there's a couple ways of doing the same thing. All right, so let's go back. Over the weekend, for some reason, the OMDB API stopped working for me, and it wasn't supporting course anymore. So I had to change it to use JSONP instead, right? And JSON, so Angular's, we use JSONP. For those of you, I think some of you are doing this, using JSONP instead, right? To support JSONP, Angular, you need to add an additional attribute at the end, right? Where you have to specifically provide an attribute called callback, and whose value needs to be JSON_callback. Exactly that, right? And what Angular does is that when it generates the call, it replaces JSON_callback with its own function name, right? On the fly, it replaces it so that when the data comes back, right, it calls this function with the data, right? So yeah, so I had to replace that and fix that. All right. Okay, so let's go back to the model we were working on a second ago. Yeah, so I fixed it. So instead of capital movie, it's actually movie, right? It's lowercase movie. So in the save, we're going to add the defer and the return so that we sandwich our asynchronous call with promises, and internally the dot save does the same thing. This is an asynchronous call. We provide a callback that we're going to use to either reject or resolve the promise, right, to whoever is calling us, right? And the service, the web service that call the create movie. It used to be that create movie used to be a synchronous call. You see that? Used to be that we would create the movie and then we would come back immediately, right, with the instance of the movie we just created that was added to the array, right? But no more. It's no longer a synchronous call. Instead, it's an asynchronous call. So this one, instead of getting the instance of the movie that was just created, instead it gets a promise, right? It gets a promise. So disappointed, right? It registers two functions that will be eventually invoked when the promise is either rejected or resolved, right? So here it receives the movie having been inserted. It's going to push the user ID in likes, and if you remember the schema for the movies only has what? Bless you. It only has the IMDb, the poster, and the title, right? So this .likes is not yet in the schema. Yeah, it's not yet in the schema, so this will be ignored, right? The mongoose says, huh, there is no likes attribute in the schema, so this is going to be ignored. We need to go back to the schema and add that attribute in the schema, right? And initialize it as an array of strings. Okay. So what do we do with this likes? The initial intention was to add the user ID into that array of likes, right? So that the movie, having a many-to-many relationship, right? The movie knows that these are the users that like this movie, right? Remember, there's a many-to-many between the user and the movies, right? The user knows which movie they like, and the movie knows which user like it. Yes, right. So this is from the movie's point of view. All the users that like this movie. Okay, and then we need to do the other case, right? We need to be able to find the user and tell the user that, hey, user, you like this movie. So the movie knows that which users like it, and we need to also notify the user that it likes this movie, right? But this is an asynchronous call. This is an asynchronous call, so we haven't dealt with that yet. We need to deal with that. We need to refactor that. Let's see, that's it. Okay. So this implementation here, right now is still synchronous. It's still synchronous. We need to fix it so that it's asynchronous, right? So there it is. So find movie by ID. Find movie by, let's see, wait a minute. Find movie by IMDb. Oh, find movie by IMDb. This is, why do we need to do this? Okay, we just keep refactoring, right? We keep refactoring these functions. It used to be that would iterate over the movies, comparing the IMDb's, right, with the array of movies. But we no longer are using an array of movies. We have to go back to the server, to a database, to retrieve all the movies. So we're going to use the model find by ID. I think that's an error. I think that should be find one instead of find by ID. I made a mistake because this is the IMDb ID attribute, not the underscore ID. Right? This one is comparing. This is comparing the underscore IDs, right, with whatever I pass. So I believe I fix it in the next slide. So again, the sandwich, right? We put the deferred. We make the asynchronous call, and we return the promise. So if you remember, we were adding the users to the likes, right? But the schema for the movies didn't have the likes array, right? It didn't have the likes array, so we couldn't add it. That was failing. So I had a bug there, right? So that so now the movie has an array of strings, and that those strings are going to be the user IDs for the users that like this movie. I also went back and says, well, might as well add the likes also to the user, right? So that the user has an array of user IDs. I'm sorry, the movie IDs that this particular user likes. In the movie service, let's see, in the movie service, this is add users to movie likes. All right, I looked at the implementation and saw that it was getting pretty hairy. So I said, you know what? I'm just gonna delegate the model, right? The model will deal with the likes. So I took this entire implementation. I took this entire implementation that used to be part of the service, right? And I moved it down to the model. I moved it down to the model, and I said, hey, model, deal with user likes movie, right? And here's the user ID, and here's the entire object of the movie object, and I'll just patiently wait for the movie. By the time you come back, both the user will be notified, and also the movie will be notified, and they'll know about each other. Okay. So again, I create an abstraction, right, and move this into a function inside of the movie model. Okay. So I grabbed all that and I moved it into the model. There it is in the model, right? I added user likes movies, right? User likes movie. So I copied all that. I put it in here, and the way it's implemented is I will fetch the movie. I will fetch the movie using IMDb, using find one, right? That has that IMDb ID, right? Once I have the movie might already be there. So there's a couple of options, right? There's a couple of options. The movie might already be there because somebody has already liked it, right? It could be that this movie never existed in my database, right? In that case, I'll need to create it, right? So here's I first hand, if it's the error, I will just reject the promise. And then here's the cases where the movie already exists, meaning it's null, or where the movie doesn't exist yet, right? This one is either because I've already liked it, or somebody else has liked it, so it has to already exist in the database, or this movie has never been liked, all right? Or nobody has ever reviewed it or commented on it or rated or anything, right? It just doesn't exist in the database. If it already exists, I'll take its likes and I'll push the user ID that was passed to me as an argument, right? And so I've updated the object, right? This is an object that came from the database. This doc came from the database, right? So once I update the object, I can go back and save it back to the database, right? Do an update, right? I've modified it, I've tweaked it, I've done something different to it, right? I can go back and update it into a database, right? And this dot save, right? Again, it returns either an error or a document, right? If it's an error, I'll reject the whole promise, right? Notice that it's the same promise. It's the same promise that was returned earlier, right? The top level promise. It can either be rejected here, right, or could be rejected also anywhere, right? Anywhere you reject the whole promise, right, that was returned, right, will be notified. Yes.
The error will be different.
Yes, whatever error, either when we were finding it, right, or when we were updating it. It'll be either both of them could be timeouts. One of them could be I couldn't find the object, something wrong went with finding the object. maybe the IMDb was in the wrong format or something, right? This one is an error when you were trying to update the document.
I mean, can we differentiate whether it's updating it?
Well, the error will have probably have information about what is it that you were trying to do, either finding or updating. You can add additional attributes to the error, right? You can add your own. You can decorate it, right? So you can say error dot my beautiful message, right? And then provide your own message in there, right? And that message you could put, unable to save objects, right? This one you could put something, error while finding a movie using IMDb, right? And then this message will go back to the client, right? And the client will need to know to look for that property that was added to the error object, right? And then you could use typically you don't want to do that on the server. Typically on the server you just want to have an error code, right? A high-level error code, and the client will have pretty messages and will have a list of messages that map to those error codes. Yes.
We are doing a find code here, right?
Yes.
If there is no, the document doesn't exist, then you should give an error.
If the document doesn't exist, so if the document doesn't exist, this will be null, but no error, right? If there was no match, then both of them will be null. Error means something that I could not fulfill your request, right? Something went wrong. There's a system level error. Not finding the document is not an error. It's just that it's not in the database. It's a legitimate, valid result. That document that you were looking for, it was not in the database. Okay, but it's not because there's an error. Okay. So this being null is being handled by this else here. All right, this else handles the case where that movie was not in the database. I didn't find it, right? If that's the case, I am going to instantiate the movie, right? And then I'm going to add the likes, right? I'm going to tell the movie that that this particular user likes it, right? And then I'm going to save it into a database. And again, this save is can either reject or resolve the promise. One problem here is this movie. This movie that came here, right, comes from where? Comes from the third-party API. So for a while, this was failing. The movie wasn't being inserted. Actually, no, the movie was being inserted, but only the IMDb was being only the IMDb attribute was being added, right? But not the title and not the poster. It's just, why not? It's because it failed the schema, right? The only property that matched was IMDb. It was correctly spelled with correct camel casing, right? But the other one, the poster was capitalized. It was lowercase, right? And the title was capitalized, and but the other one was not capitalized. So after a while of banging my head over it, I fixed the movie instance. Right, I fixed it and says, okay, so I'm this mapping, right? I need to do the mapping between the two schemas, right? One is representing using capitalization, and locally it's not. Okay. It was also giving me. Oh no, that's it. Yeah, that was it. Right, and then I pushed the likes and saved it back. Right. Well, so I fixed it everywhere I could find. Okay, so we've now the movies know about all the users that like it, right? We need to do the mirror image on the user side, right? I need to use a fairly similar technique, right, to update the users and tell the users which movies they like, right? So I moved all the code that used to be in the web service. I moved it into the model, into the user model, and encapsulate it into this function called user likes movie, which is the same thing, right? It's the user ID and the movie. This is the movie object, right? I need to remember if I'm going to encode it there, right? I'm going to first find the user by ID. To find the movie, we use find one. Remember? Because I wasn't going to find it by ID. I was looking it for IMDb, so I had to provide the IMDb predicate. Here, I am looking for the users by a user ID. So I use the find by ID method instead. You see that? Right? Both of them just return a single instance. Both of them, right? If it fails, I reject it. If it doesn't fail, I'm just gonna add the movie IMDb to the likes. Okay. Notice that in this case, I'm not checking whether the user is null or not. Okay. I'm pretty confident that the user does exist, right? And that the document is not null, right? Although it would be a good idea to do some validation, make sure that this document is not null, right? Although it would make no sense, right? I only got here because I have already liked the movie. I'm sorry, I've gotten here because I was able to log in, right? I was able to click on the likes, right? And already there's validation that if I try to like and I'm not logged in, it's going to kick me out to the login page, right? It's not even going to get here, right? So the only way I got here is because I'm already logged in. I already have a user ID. I'm already in session, right? And this ID does exist. Nevertheless, it would be a good idea to put this inside of an if statement, right? If the document is not null, then do this. It's good practice. Okay. I was lazy and I kept going. I was confident that the document was not null. I pushed the IMDb into the likes, and then I saved it. I saved the user. I saved the user back into the database, right? And then again, reject or resolved. So in the movie service, meanwhile, in the movie service, user likes movie. We had implementer user likes movie, but these need to be synchronized in such a way that when the user is notified, when the movie gets notified that such and such user likes it, we also have to notify the user that it likes such and such movie, and that have to happen like a transaction, right? Remember that this movie service is still responding, is yet to respond to the server. Well, actually, it was before, right? It was responding. It was only responding that the movie knew about the user, right? But we had not yet updated the user that it likes the movie. So we would have some inconsistency, right? If we were at the movie page, it would show that so-and-so users liked it. But when we navigated to that user, right, profile, the movie would not be listed in the profile. See that? It would be an inconsistency. So we need to do both, right? They have to be done both. So here's where we're notifying the movie of the user that liked that movie. And here, instead of responding right away with the movie, right, we're gonna first notify the user that it likes the movie. See that? So that both know about each other. Okay, and they're both asynchronous calls. They're both asynchronous calls. We could have done this, right? And in the next line, we could have done that, right? But now we would have had two threads, right, in parallel, one updating the movie and one updating the user in no particular order, in no guaranteed order, right? And we could have inconsistency. It could be that depending which page we were in and which one came back first in no guaranteed order, it could be that we look at one page and it's correct, we go to the other page and it's incorrect, or vice versa. We want both pages to be correct, right? So we want to serialize these asynchronous calls. We want to make sure that they happen in a particular order. Yes? Right? So here we're notifying that the movie likes the user. And then in the callback, when it comes back that the movie is all done, we're going to go and fetch the user. It says, hey user, you like this movie, right? But it too is an asynchronous call. So notice that what does it return? A promise. So we need to resolve it. And it gets resolved after the then. Right here, there's another then. See that? This then is to handle the promise of the movie being updated. This then is to handle the promise of the user being updated. Again, this is to handle the movie promise. This is to handle the user promise. Okay? So notice that these then can be written as siblings of each other, right? And what you end up is with code that looks sequential. It looks sequential. If instead we would be using callbacks, right? You'd be writing code that looks, all indented, right? Especially if you have more than two. Here we only have two, right? So you don't appreciate as much. But imagine you had 3 or 4 or 5 of these that are nested, right? That are dependent on each other, right? That this has to happen, and then this has to happen, and that has to happen, right? Imagine, I want to go to Chicago, and I need a reservation on the plane. I need a car rental when I get there. I need a hotel, right? And 3 things have to happen, right? And they're all asynchronous, right? They're all happening asynchronous, and they can happen in any particular order, right? I need to wait for all of them to come back, and if anyone fails, I don't want to go. Make sense? So you could imagine that when you have long-running transactions, right? That they all have to happen in a particular order, or they all happen, or none of them happen. You would end up with these heavily nested callbacks, callback, right? The promises API allows you to write it in a more sequential, the way we would expect it, happening in sequence.
Professor.
Yes.
So over here, so when we called, I think user likes movie, so it would return a movie, right?
This one?
Yeah.
This is the return. This is the promise that is returned, right, when we were updating the movie, telling that the movie likes a user.
Okay. And if that promise is successful, then only it would.
Yeah, it would get here, right? It would do this if it's successful.
So what if we have one more return, and the first one is successful, so it would change the DB.
Right. So the first one is successful.
So it would there would be change in our database.
Yes.
The second one is unsuccessful. Okay. Now how to revert?
Yeah. We would have to revert that. We didn't do that here, but yes, we would have to revert it. Yeah. So in this function, when it failed, right, we would have to revert the change in the movie, right? Because it would make no sense that one succeeded but the other one didn't, right?
So it's like the example that you showed us.
Yeah, exactly. Right, exactly. Here you would have to go back and revert that. Yes, before going back to the client. Yep. Good point. Yep. Perfectly, you would handle it. You would put it all in a running transaction, right? You would say you start a transaction, begin, right, and then you would only commit when you get here, right? When you get here, that you're about to come back to the client, you do a commit, right? You do a commit, and then both would go from a temporary update into a permanent update. Yes.
So if there is an error in the first then.
Where? I'm sorry.
In this function.
Yes.
So if there's an error, so we like return null.
Yeah, right here we send back a 400 to the client. Yeah, it just goes back. We are resolving the response. See that? We're doing the response. We're not returning this. The user model update never started. Right? We are responding to the client immediately with an error. Right?
This is like a series of right? Is there another variable value?
Yeah, the QAll. The Q.all that I mentioned earlier. right? Where you don't care what the order that happens, right? You're just waiting for all of them to continue to complete, right? You would use an array. You say q.all an array, right? And you have all these function calls, function call, function call, function call, all of them responding with responses, right? And qall will wait for all of them to come back. And when they all come back, you have a dot then, right? If they all succeed, right? They all if they all come back with a success, meaning they all say a resolve, 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 right? Then the success of the then is called. Otherwise, if anyone rejects, so they all have to return resolve for the successful of the then, right? But if any one of them rejects, then the unsuccessful gets called. Yep.
And writing then over here is the same way writing then, like if I don't have a return statement over there, I will call user model dot user like movie dot then over there.
Oh, here, the dot then?
Yeah.
Yes, but that's what we want to avoid, right? We want to avoid having these nested, all these nested things, right? That's why we return. Well, we return the promise so that this whole thing evaluates to this promise, right? So this object then is the object that is being returned by this. So the then evaluates to this return, right? Which then is caught by this then over here.
But I think the whole idea will be the same. If we write then over here, then it would be still sequential, and if I write then over here, then it would
Yes, there
but it would
you
be like a better
yes.
way of writing.
Yes, yeah, the whole point of even using this these promises is so that you get this clean sequential, that you can write these clean sequential code and avoid having to nest them internally, right? The whole point. Yep. Okay. Yes.
You know that, yeah. Suppose if we have one more nested function inside this one.
Yep.
So then so that would come below this one.
Yeah, exactly. If say you want to do something else here, right? I don't know, whatever. You need to do another asynchronous call. You would do again. You would say return whatever that asynchronous call is, right? And then you would write a then underneath here, right? And so you can write any number of them, right? All of them returning promises, returning promises, returning promises, and being caught by the next then, by the next then, by the next then, and they will execute in that sequential order, right? As opposed to passing callbacks, passing callbacks, passing callbacks, passing callbacks. This one calling the one above, this one calling the one above, calling the above. You end up with this, very diagonal programming, hard to read. Okay, make sense? Yeah. Once you do a couple of these, right, and the whole the idea of doing your assignments and doing it for your projects is to practice this. It becomes second nature. Yeah, it's a completely different way of thinking about programming. We have our minds so we've spent years and years learning about von Neumann machines, right? Everything executing from top to bottom, from left to right, right? That it's hard to unlearn some of that, right? It says, well, no, wait a minute. This what if things are running everywhere, right? And how do they talk to one another? How do you synchronize among them? Right? And it's event driven. It's everybody's doing whatever, right? And at some point, somebody goes and sends you an interrupt. Says, wait a minute, let me listen to you, right? And then so how do you synchronize these? So this is an API that allows you to do that. Meanwhile, in the profile, why is this taking so long? So in the profile, so if you remember the profile, we want to when we get a user, right, in the scheme of we don't just want username and emails and roles and we don't just want the IDs of the movies. We want the movies, right? Because we want to render in our profile page. We want to render, the poster images, right? The titles, right? The ID of the movie, so that if we click on it, we can navigate to the page for that movie, right? So when we get in the profile page, we want that data. There's two ways of doing it. One way of doing it is I go now I'm at that profile page, right? I have the user information, so I display the top half, right, with the details page of that user. And what I could do is then generate a second call, right, and go fetch the data related to this user, right, using the user ID. I could say, well, go fetch me the movies that this user likes in a separate call. Yes, I could do that. And also, there could be many things that this user is related to, right? The user is related to many movies, many reviews that the person has written, many comments, other users that he's following, or other users that are following him, right? I could have lots and lots of relationships, right? And what I could do is maybe use tabs, right, to show different relationships, right? If I click on follows or followers or whatever, I go fetch that data and retrieve it dynamically. I could do that. And that's the preferred way of doing it, right? You go fetch them on demand, right? On demand. Whenever you need it, you go fetch it and you update the user interface. An alternative way of doing this, right? An alternative way, and also because it allows me to introduce a new topic. Another way is that the user schema could have internally an embedded schema for the movies, right? Meaning, say I don't care about followers and follows and have all these relationships. I only have the relationship that I like these movies. Maybe that's it. That's all I have, right? So in my profile page, I have a pretty simple profile page. I just have the personal information at the top and just the movies I like. That's it, right? So instead of having two separate calls, right? What I could do is to whenever I get the personal information of the user, I could, because I want to render on the same page, embed the data of the movies, right as part of the user itself, right? Embed the title, the poster, the ID of the movies, right inside of the user itself. And here's what I'm doing. See that? In my user schema, I'm going to add an additional attribute that is going to be an array of the movie schema. See that? Right? The movie schema, I can load it dynamically. There it is. I can require it. Right? What does the movie schema have? It has a title, right? It has a poster. It has its own likes. And so I'm going to embed the schema as a subset of the likes movies, right? And so that when I'm fetching so that in my service, in my user service, when I was finding the user by ID, find user by ID, once I had the user here's the user. Once I had the user, I could use the likes of the movie, right? These are all the IMDb IDs of all the movies that this particular user likes, and pass to a find movies by IMDb's. See that? As a separate function call that will take the arrays of all the IMDb's, right? Go to the database, fetch all those movies, right? Return all those documents as an array of movies, right? And populate, right? Now I have all the movies, returns a promise, which will be cut by this then. Now I have all those movies. And those movies, I'm going to set them to the likes movies. Likes movies is an array of movie schemas. What are these? It's an array of movie schemas. Okay, so they match. Now when the user goes back to the profile, it'll not only have the personal information, it'll have also the populated movie objects, so I can render them at the bottom, right? But notice how I did it, right? Notice that the way this was implemented is that I added this to the schema of the user. Now, some might say, well, what do you mean? Are you going to store this in the database? The database of the user, going to have the record of the user, is going to have also the movies embedded in there? No, that's not what we're going to do. Okay, notice that when we the user, we never went back to this database and saved it. Okay, so the database actually never knows about these movies, right? It only knows about the IDs, the IMDb's, those it knows, right? But the actual instances of the objects never make it to the database. They're only updated here in the object only for the convenience of the client, the AngularDB, the AngularJS client, right? So that it can render the titles and the IMDb IDs, right? It's only for rendering purposes, not for storage purposes. See that? Okay. Yes.
So now the schema has changed. So anybody making the find call would again fail because you don't have that schema in your MongoDB. Like for
No, it won't fail, right? If it's not there, it'll be ignored. It'll be an empty array, right? If the
no, but the documents won't have a like for movies field over there.
Yes.
In the database.
That's fine. Only the ones that match will be matched. So so first of all, it's not going to make it into the database because we're not going to save it.
Yeah.
So actually, none of the documents are going to have this attribute because we're never actually going to save it.
So, but all the documents would have an empty array of like for movies over there. Response having the movies embedded into it.
The reason this user is a reference to this document, right? And this document is a model that was created from that schema.
We can have object of the user.
I'm sorry?
We can create an object of the user.
Yeah, I mean, we could create a separate JSON object, right? It could be and we have to copy everything over, right? We have to copy everything over, and that's also very common for objects or objects. These are objects that are only meant for transferring data back and forth, right? They're not meant for storage or logic, right? They're meant for serializing data back and forth between two network connections. Yes, that is a valid solution, right?
Because in the DB there would be one more field having an empty array. So I thought.
Yeah, it would be an empty array. Yes.
So
Yep.
we can just have a.
Yep. Okay. So we have to implement this function here. Find movie by IDs. I don't know. Remember that? Okay, I think I ran out of time. If find movie by IDs finds the movies by IDs, iterate about the array. Notice that it's using find. It's using find. It's checking to see if the IMDb is in the array of IMDb's. See that? Right. So finder, right, has you can use predicates with operations such as greater than, less than, not equal to. There's a whole bunch of operations, mongoose operations that allow you to compare values against other things. This one is in, so you can provide an array of IMDb's, and anything that has the ID in the IMDb will match. Right, and notice that it returns an array of objects, of instances, right, and that's what we're returning as movies, right? All right, I need to leave it here. Again, please read on the documentation in Mongoose, okay, and MongoDB, that we mentioned earlier. Oops. On